This is a video on limits. The question states, find the limit as xy approaches 0, 0 of x squared y over x squared plus y squared. So here we're going to find the limit, which means we want to show that it exists and then find what it is. So it's not enough to just look at a couple paths and say that paths go to the same place, so the limit exists. We have to show all paths. That would be impossible. So instead, I'm going to convert this whole thing into polar coordinates. Let's recall that for polar coordinates, x is equal to r cosine theta, y equals r sine theta, and x squared plus y squared is r squared. And also, if we're approaching the origin, any path that approaches the origin is such that the r goes to 0, and that's because r corresponds to the distance from the origin. So we can substitute. We have x squared, which is going to be r times the cosine of theta quantity squared, times y, which is r sine theta, over x squared plus y squared, which is r squared. And we're taking the limit as xy goes to 0, 0, which becomes the limit as r approaches 0. So now we can simplify a bit. We can square this out and get r squared cosine squared of theta and say the r squared from this r cancels this r squared. So the denominator just becomes 1 and it goes away. And we're left with this r from the r sine theta. We have the cosine squared of theta times the sine of theta. So cosine and sine are both continuous functions that are always between -1 and 1. So in particular, if we multiply cosine squared theta times sine of theta by r, which is approaching 0, then we get 0 times something between -1 and 1, and that's just 0. So I can conclude that the limit as xy approaches 0, 0 of x squared y over x squared plus y squared is equal to 0. And I'm done with the problem.